Hi guys, so I'm back. I would like to introduce myself. My name is Eva. I am a chemist, but I work a lot as a programmer, and I'm trying to make my own device that people are gonna use in a library, in a laboratory. And well, you see, right? It is controlled by STM32 board. This board we made ourselves, and yeah, let's go to it. So I'm using TouchGFX mainly because well, this is the official one. This is the official framework, the UI framework for STM32, and it's actually quite nice and robust. And again, I get used to it actually. So yeah, and it gives you a lot of variability. So what is my device? My device is multifunctional titrator, but it's more like let's say a burette probably. So the idea is that we're taking a lot of sensors. We're taking 1 or 2 peristaltic pumps, and we control it. So you can make a titrator from it. You can make a very nice burette that people will be able to use in let's say in a reaction. So if you're a chemist, a synthetic, you will be able to, and you're making an experiment, yeah, and you have to add something to your reaction mixture, but you have to keep the temperature stable. So this is so common when you have to cool your reaction down and to add some reagent no more than a certain temperature. And my device is able to do it. This actually here. So from the main menu, this is the main menu. We go to the quick task. You see it right here. Yeah, we go into from quick task. We go to the quick task menu, and let's say we go to burette. This is here probably, or yeah, I'm gonna go here, and then we can select the temperature, show how much, what is the range, and it's gonna the titrator will add the specified volume at the specified speed, but once it reaches the temperature, it will stop and it won't proceed any further. So let's go back. So what is the task for today? And today's task is actually to finish the pH adjustment. Yeah, so we have here adjust setup, adjusted guy. We had several problems here. So the first problem was that if the user we didn't have this, this is just the most recent edition. So we had just pH or ORP, we had final value, and we had continuous. So what each does, and what is this method for? This is actually like our primary. Like, I have a friend who bought the prototype, and his the main job that he does is that he is precipitating something from his reaction. Well, usually, yeah, and this is not like organic reaction, it's more like his inorganic, and he has to keep the pH of the of his reaction mixture in some range. So the idea is that we select pH, he specifies the value to which he wants to go. Let's say this pH 9, and then he starts to add, and the device starts to add the titrant. Okay, I don't know how to pronounce this word. And of course, the pH gonna increase. It goes up because the titrant, let's say we took sodium hydroxide, it goes up, and at some point we reached the final value and we have to stop. But once we stopped, there was a fault in the logic of the program. So so let's show it again. Yeah. So here we have our project, and this is all the all the files that I'm using. And for the burette, it's actually like Wacatec burette. Yeah, so this is, here we see the main loop for the burette, and I have the underlying structures as, again, as a tasks. This loop goes like this. So first of all, we collect the data, and if we are not yet started, we have to see if it is okay to start. Yeah, so burette, our start criteria met. And here we see if they are met. We look for each start criteria that is set up, and if they are met, actually, yeah, then we can proceed. And on the next loop, we want it will be already true, it will be already 1, so we won't check it again. Once it's started, we're gonna check for the errors, we're gonna see if the criteria are met, we're gonna calculate the results, if they are met. If they are not, then we're gonna check if the addition is finished, if the waiting time passed, and so on. And so on and so on. Again, like if and criteria meet, and if addition is finished, I think like here I should add, yeah, if is finished. If it's not finished, yeah, then we have to stop. Peristaltic. Okay. Pump. Stop. Complete. Tux. Current. Stop. Okay. Yeah, that's a nice addition, because of course otherwise, if the end criteria met, the pump will just go on and go. You know, guys, like this loop is going on in Wacatec main function. Again, here we have a lot of threads, and I'm using Azure TOS. This is a very common, this is a very sophisticated operating system, but it gives you really good control, like all of the flags and mute access and semaphores, and I'm finding a good use for all of it. Yeah, so what's next? And what was the problem? So go in here, let's see what we can do. Our task for today is the following. So the user should be able to show what is the titrant. Okay, I got to see titrant how to pronounce this, because I'm okay. Trent, sorry, and it always shows me in Russian, even if I really am not. Like I ask you in English, why do you show me this in Russian? Trent, okay, so how do you pronounce it? Trent pronunciation. Okay, let's hear it. It's a whole minute video, and probably like 30 seconds of it gonna be just like the intro. Anyway, like let's hear it out. Let's hear what they have to say. As I'm talking, as I'm telling. Like
Titrant.
Titrant. Yeah?
Titrant.
Titrant. Oh, so this is a titrant. Okay. Titrant. Nice. So, titrant. So the user has to specify the titrant. And of course this titrant should have some properties such as acidity, the formula, the titer, and so on, like many of them. And if you're interested, where do I keep all of my all of my definitions, I have the header for it, Wakatek something structs, and here we have, where do we have it? Structs, titrants, this is for step motor, and I believe it's lower. These headers became very big in no time. I should probably at some point of time to cut it out for a few, or for let's say, how to say it, like for a smaller, yeah, to make it smaller into pieces. But anyway, so let's go. Here we have the burette, yeah, struct, that was the burette at point struct, burette task, yeah, burette parameters, burette end criteria, titrant struct. Okay, so here it is. Yeah, and of course, like this task struct, the big task struct for the burette, it has the titrant. It has the titrant, has the sample, it has the start criteria, parameters, and criteria. Yeah, and all of this you see here. Still, nevertheless, we are now interested in titrant, and the titrant struct has the following. It has name, it has its titer set, titer is concentration set, concentration. I would add is pH set, or pH, so this is the pH of the titer of our titrant. Okay, I should definitely hear it again because it was so funny. Okay, let's hear it. Titrant. Let's hear it out. Oh, go on. You can do it. You can do it. God, it's
Titrant.
Titrant. Nice. Titrant. So, let's go. We have pH. Of course, we will add is RP set and AT. No, float RP. This is nice. Okay. So I changed it. I'm now on my laptop, and my laptop is really okay. Does it work? Yeah, probably works. Maybe not. I'm not sure. Anyway, so yeah. Oh, for God's sake, it is so hard for it. So hard. And let's see why it is the camera on. Let's see if the camera is on. No, it's not. Man, this is so hard for this laptop. I really need to buy this the stronger one, but I actually don't have the money right now to do it. It's actually like, you see, like all of this is done to get some money, not anyway. So somehow I don't. Okay, yeah. So I have myself back again, and it's nice. My PC is running really hot right now, but it can be done. That can be expected. Tighter is tighter set, PHP or P, and probably I would like also the volume set. So the max volume that there is. Okay. So what do we have now? Let's go to this menu, and this is Edge setup menu, and let's work for these buttons: auto, basic, acidic. All of them are toggled, and for all of them I will add some interactions, and let's do it. I definitely didn't add it yet. So button is clicked, choose click button, titrator auto, action, call new virtual function, button, auto, clicked, copied, placed. Okay, the next one is basic, button is clicked. Now we go to basic and call new function, titrator basic clicked, and no, I don't want to delete it. And finally we're gonna have acidic. Button is clicked, button titrator acidic, call new virtual function, acidic, control copy. Yeah, so we have all of this. Now we have 3 virtual functions, and they're gonna be defined in, let's go here, let's close this, in TouchGFX, in GUI source. This is a just setup. These are presenter. This is our CPP file, header file, and here in a generated base file, we're gonna have our functions. Let's go back. Let's replace them here. Now some kind of mundane. Okay, delete. Okay, and let's go back to the C++ file. we'll go here, we will copy this one and change it to this, replace all, close. Now we will have something very similar to what we have for the buttons ORP, pH and so on. So if titrant auto is clicked, yeah, so this button titrant auto get pressed. Yeah, if it is pressed, PS 1%. If it is not pressed, yeah, let's do it like this. Set pressed. Yeah, true. That else also true. So this will make this button we won't be able to unselect it and press it if by pressing by this button. Yeah, we want it as a run. So once we press it, so will be the, I'll show it in a second. So if it is pressed, yeah, and then we have our task, yeah, task titrant, yeah, is pH set equal to 0. Okay, that's it. Yeah, and invalidate. And very similar, we're gonna have to here, but with one addition. Yeah, so like if button titrant auto, not titrant auto, if titrant basic get pressed, get pressed, yeah, and of course then we have to set this one false. I think this I can optimize it and just place it over here. Yeah, definitely I can do it. So auto and acidic. Copy and compost. Okay, that's nice. Basic get pressed, and here acidic get pressed. So if this is acidic, then pH1 task titrant pH will make it equal to maximum minimum pH that we have. If the basic one, yeah, then we have something very similar, but the pH will be different. And of course here we just have 0, and I'll probably have to copy it over here, but let's make it 0, and then we don't need this one. We have this true, this false, have basic true, false, 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 true. Yeah, okay, so this should work. And then we're starting this. Okay, let's see if it works as intended. And now I'm gonna send it to the board. Let's see if the board is clearly visible. The board is definitely clearly visible. Okay, so it takes some time because again, like, I don't have a very nice laptop still. It won't be that long either. Actually, like, the bigger there's a lot of time that I spent for just downloading the firmware, and as you see right here, I'm not even uploading the part that goes into the external flash. I have 16 megabytes that I use to store TouchGFX data, like all the graphical data and so on. For this board, we are using W25Q128 chip. This is a NOR flash, and yeah, in quad SPI mode. So I made a memory mapped mode. It all works. I created my custom downloader as per tutorial. Yeah, that I saw. Where did I saw it? Yeah, like STM32 official one. There's the tutorial how to make it. I can guide if I'll have the time, and if somebody needs it, yeah, I can make a tutorial of how to do it. But anyway, so what do we have more? There are more. So this one is building, and while it does building, I'm gonna show you what I want to do. Yeah, so like in the burette, we have this function that is no, not a stabilization, not a set titrator point, calculate volume adjustment. Yeah, adjustment. So calculate volume adjustment. I think adjustment is probably the better term, but anyway. So what do we do here? Once we have the parameters pH that we want to change to go to some pH, and we will see with each tick, with each addition, if we moved anywhere. Yeah, like did we moved? And the problem is here that sometimes you add I don't know, you added a titrant, but nothing changes, and maybe even like pH goes into the different direction, which is very bad. And also, like, you can possibly start, like, you wanna go to pH, let's say 8, and you've added sodium hydroxide, but at some point the task goes in loop. It goes, and you just overshoot. Yeah, you go to the pH 9, and it goes into wrong direction, of course. Like, you cannot add more, and the device should either calculate the titrant specifications, like it should understand, okay, so what am I adding, because you cannot do it blindly, of course. You will add too much errors. But or either it should be specified by the user. So here we have, like we've added is.ph set, we've added all of this, and now we will function actually. Like over here, if ph, we'll see. So this will be the place where we are doing this. So anyway, let's go here. I'll go into this, go into adjust. No. Yeah, here. See? It works. It works just as intended. So we've created something like radio buttons. And don't be afraid that there is no text. This is just because we did a no flash download. Again, I have several presets with no flash, like no external flash for the imagery, and with the flash, but it takes a lot of time. So let's go to burette. Let's go to burette. See right here. Yeah. Current. This one. So first of all, I have here volume to add, minimum volume to add. I would like to delete it. Yeah, like this. This one, I don't need it. Okay. To add, current max volume to add. This volume set. Let's add data, burette, step, current equals 1. Like this is just yeah, so like we can actually place else in here. Yeah, if equals 1, nice. Else do this. Okay, but if it equals 1, then we are data. Okay, where is it? Is this one? Burette point. Let's go. Let's place it over here and make it like this. Yeah, so the purpose of this line is, this is the first step. Yeah, of course we don't have any data, so let's add the minimum volume and see what happens. We can also check for this one, direction. If data burette task current titrant is ph set and if data burette like this, and we have index, of course, is 0, ph set. Nice. So 0, So what do we do? So what do we have to do it here? If titrant pH set, and if we notice pH, so we have 3 points. We have a target, parameters pH, so this one. So we have 3 pH, like this one. This is the pH where we want to go. This is the pH that we have, and this is the pH of titrant. And what do we have? Like if, so if the current pH is on the other side, how do we make it mathematically? So so let's do it like this. If current parameters pH is less than For God's sake, I have some problems with my touchpad. So let's say it like this. If our current pH is more less than the pH but more than titrant pH, then this is the problem. I should just transfer it so it will be clearer. Okay, again, like basically we are making sure that both that the pH that we have right now is not inside the interval of the pH that we want to have and the pH of the titrant. So if the pH is less than pH, but the pH is more than titrant pH, nice, okay. So then we will add no title, but we will have what will we have? Goes into another titrant is wrong direction, notification level, and we're gonna go warning. Okay, again same here, but we will make here we're gonna have more, here we're gonna have less. And of course, like we also add equal for very and we don't want to add anything. Yeah, like we have to. And I probably want to pause. I don't know. And hard code here. Hard code here. 0, 0. Nice. And then we have here. So okay, let's stop for today because I have my head aching already. I'm not used to stream, but hopefully in some time I will be better at this. See you tomorrow. Bye bye.